Hello, guys. Welcome to Ramta Solutions. Welcome to your organic molecules series. Today, our lesson focuses on alcohols, and this is all you need to know about alcohols. Okay, of course, their functional group rather is hydroxyl, right? Is the hydroxyl group. Okay, oh yeah. So, how is this video structured? One, we are going to give you a brief of what alcohols are. Okay, we are going to give you a brief of what alcohols are, their properties, of course. Then we are going to be giving you the generic naming of alcohols, and then conclude the video with examples where we are drawing and naming structures of alcohols. Okay, all right. So, alcohols. You guys already, I did say that they have a hydroxyl ion. So basically, these are hydroxyl ions on your saturated hydrocarbons. All right. So these are saturated hydrocarbons with at least one hydrogen atom replaced by a hydroxyl ion. Okay. Remember, it is not that only one hydrogen atom will be replaced. In other words, you can have more than one hydroxyl. Okay, you can have more than one hydroxyl ion in a molecule. Okay, all right. Then alcohols, guys, they are more reactive than alkanes. That's a fact. And you have one alcohol that a lot of people know is this one here called ethanol or even methanol. These are the famous alcohols, right? These are the famous alcohols, especially ethanol, because on weekends, oh boy, it's a beverage for the weekend, the ethanol, right? All right. So as you can see, these two names have something in common. Look at them. They have all. Can you see that? And the an is basically from the fact that they are from saturated hydrocarbons, ethanes, right? But because you're substituting or you're replacing one hydrogen with hydroxyl ion, you then say all. Okay. So therefore their suffix is ol, all, and their general formula, it's almost similar like that of the alkanes, but you say instead of 2n plus 2 and O, you say 2n plus 1 OH. But it is the same if you look at it. CnH2n plus 2H. Isn't it the same? When you look at this, it is, sorry, not plus 2. My mistake. Not plus 2, man. What am I saying? Plus 1 would do, but plus 2, it's fine, in fact. It's fine as plus 2, isn't it? It's fine as plus 2. So when you look at this, it is alkanes. All right, it is alkanes. So it is, yes, you are replacing with with a hydroxyl, but when you look at it, when you look at the number of hydrogens, they are the same as they could be in an alkane. Do you see this? But of course, do not use this. This is the general formula of alcohols. Okay, but if you are to manipulate it further, it'll look something like this, isn't it? This is where you get its molecular formula, but generally this is also okay. All right, so this is the general formula. So I did mention that one, your common alcohols are methanol and ethanol, and I also need to mention that these alcohols can be classified as primary, secondary, or tertiary alcohols. Guys, this is not different to how carbons are classified. You remember, primary carbon was attached to only one other carbon. Secondary was attached to two other carbons. Tertiary was attached to three other carbons. Now, with alcohols, it is like that. Primary alcohol, with the primary alcohol, the OH to a primary carbon. The secondary, the OH is attached to the secondary alcohol. The tertiary, the OH is attached to the tertiary carbon. You get it? I repeat, primary alcohol, the OH is attached to the primary carbon. Secondary, the OH is attached to the secondary carbon. The tertiary, the OH is attached to the tertiary carbon. So it's not different to how we classified carbons. It's the same, okay? Oh yeah. Remind me please when we draw structures to remind you whether a molecule is primary, secondary, or tertiary. Okay. Now, one thing about alcohols is that one, they are colorless and they are basically acidic. They have that bitter taste, acidic. Of course, I know when I say acidic, I shouldn't be saying bitter, because when I say bitter, I should be saying basic. So yeah, they are acidic in nature, right? They are acidic in nature. Now, further about alcohols is that because they are from saturated hydrocarbons, they can undergo your elimination, and you can also substitute the hydroxyl. So they can undergo elimination and substitution reaction. Okay, we did say this, and we did say that they can undergo elimination and substitution reactions. So again, the small alcohols, ones with carbon 1, 2, 3, they can dissolve in water. But this solubility, them dissolving in water, this solubility rather, decreases as the molecular size increases. So as you move from carbon 4, 5, 6, and so on, the solubility decreases, right? Their solubility decreases. Now, you recall that we said they are saturated hydrocarbons with at least one hydrogen replaced by a hydroxyl ion. Hydroxyl ion is OH. Now this gives rise to hydrogen bonding, right? It gives rise to hydrogen bonding. Now, since it gives rise to hydrogen bonding, it will therefore mean that alcohols are generally have higher boiling points compared to the alkanes of the same size. So if you are to look at methane and maybe methanol, methanol will have a higher boiling point than methane. Why? Because of that OH. Okay, because of that OH. Remember, the O is the most, it's also highly electronegative atom. Hence, they will have a higher boiling point. Okay, but we are going to look at this later in that video where we are looking at physical properties. Okay. Oh yeah. So how we use our alcohols, here are the uses. Your methylated spirit, this is methanol, and your bev, that's your ethanol. And in your cosmetics, alcohol is used. I remember in the previous video I was reading instructions, not instructions, but rather ingredients of the air freshener. Maybe let me get it quickly. Let me show you. So this air freshener has ethanol as an ingredient. Okay, this air freshener has ethanol as an ingredient, so it is used in cosmetics, even in your air fresheners. Alcohols are also used in pharmaceuticals, and of course they can be used as fuel. Can you see this? They can be used as fuel. Okay. Oh yeah. Now, how do we name alcohols? How do we name alcohols? The naming is roughly the same as your unsaturated hydrocarbons. Okay, it's roughly the same as the unsaturated hydrocarbons. Or should I say, yes, by that I mean you also have to specify where your hydroxyl ion or ions are. Okay, so one, you recognize the functional group. What is the functional group of the alcohols? It is the hydroxyl, the OH, isn't it? It is the hydroxyl, the OH. Two, you find the longest continuous chain. What does it mean? You need to find the maximum number of carbons, right? Maximum number of carbons in your chain. Bar substituents, okay? By that I mean exclude substituents. Okay? Then when you number your carbon atoms, you need to begin with the end nearest the substituent. Hence I was saying it is the same as your um unsaturated hydrocarbons. Remember, you begin with the end nearest the hydroxyl, right? You begin with the end nearest the hydroxyl. And of course, you name each substituent. This is what we've been saying all along, right? This is what we've been saying all along. That you begin, when you name, you begin with the number of the carbon or carbons where each substituent is bonded. And you must also include the number of the carbon where the hydroxyl is found, right? Then when you have two or more substituents, you need to list them in alphabetical order. If your substituents are of the same kind, you use your prefixes di, tri, tetra, penta. This is what we've been saying all along, right? The same applies to your alcohols, hydroxyls. If you have more than one hydroxyl, you must use these prefixes di, tri, tetra, and so on. Okay? Oh, yeah. So, remember we said alcohols are saturated hydrocarbons with at least one hydrogen replaced by a hydroxyl. So it's like you expect the name methane, ethane, propane, blah, blah. But because they are not alkanes, they are alcohols, they have hydroxyl. You then say the methane, ethane, blah, blah. You substitute that E of your alkanes with OL. Right? You substitute that E of your alkanes with OL. For example, longest chain of carbon 1, methanol, ethanol, propanol. Now, when it comes to butanol, pentanol, and so on, right? When it comes to ethanol, butanol, and so on, you will say they are. Sorry, when you come to butanol, pentanol, hexanol, heptanol, octanol, we used one because this is the simplest we find of this number of carbons. But the naming can be different because the OH can be in other carbons and not the first. Okay? All right. So we are going to learn more on this. I don't want to dwell much on this because whatever that we are saying here is similar to what we said with hydrocarbons, that the double bonds do not necessarily be on carbon 1, they can also be on carbon 2. Okay. All right. So normally about alcohols is that they are liquids. Normally they are liquids, right? So I'm ignoring this part here. Okay. They are liquids. Okay. Our substituents, we have been dealing with substituents in all the videos. You have methyl, ethyl, propyl, isopropyl, and butyl. We have been dealing with them, so I don't want to waste much time on them. Right? I don't want to waste much time on them because we've dealt with them in all the other videos so far. Right? Now, having said that, we then can say, let's go to naming and drawing the structures of our alcohols. Okay, we're gonna have about 8 examples. So let's not waste time. Now let's begin with methanol. Let's draw the structure of methanol. Meth means 1, right? Meth means 1. So all would mean that they have a quadratic formula OL, isn't it? So we have not quadratic formula. What am I saying? They have a suffix OL. right? OL means they have OL means they have a functional group OH, right? Hydroxyl group. So meth, we said it's one. Normally, because it's methane, we know it is H, 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 and then this guy here. Okay. So this is the structure of methanol. Okay, guys? This is the structure of methanol. Now let's try this one here. I'm gonna try and I'm gonna try this one here. It is, perhaps let me try this one here. CH3 CH open brackets OH close CH3. Ooh, I see an OH. All right, I see an OH. Therefore, the name will end with OL. How many carbons? 1, 2, 3. I see 3. I don't see any substituent. Therefore, it means it's going to be prop. Okay, it's going to be prop. So this, to me, looks like it's going to be propan 2-ol. This looks like it's going to be propan 2-ol. Right, to me, it looks like it's going to be propan 2-ol, or if you like, you can say 2-propanol. Okay, if you like, you can say it's 2-propanol. Now, let me show you the structure now. The structure is the first carbon has 3 hydrogens. The second carbon has 1 hydrogen and an OH. The third carbon has 1 hydrogen, rather 3 hydrogens. And when you look at them, it's 1, 2, 3. That is the longest chain of 3 carbons. And where is the OH? It is in carbon 2. Happy? Perfect. Now, let's now try a different one. I want to make this one a bit complex. So it's going to be, let's see. Okay. And then, oops. Okay, let me end it here. Okay. So let's begin now. Let's count the maximum number of carbons. 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4, 5, 6. Remember, we begin numbering with the end nearest the hydroxyl. Right? So I see here this is 6. Therefore, the name will be hex. And then I see the functional group OH, implying that the name will end with ol. Now, where is this? It is in carbon number 1. So you can say this is 1 hexanol. Right? You can say it's in 1 hexanol, rather it's 1 hexanol. Or you can say it's hexan 1 ol. What is the condensed structural formula? It is CH2 open bracket OH CH2 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 CH3. Do we really have 4 CH2s? Yes, 1, 2, 3, 4. 1, 2, 3, 4. Correct. Do you see this? This is the condensed structural formula. What about the molecular formula? The molecular formula, we have 6 carbons. Remember that structure of alkene, CH2N plus 2. 2 times 6 is 12 plus 2 is 14 and an alcohol. Let's count them. 3, 5, 7, 9, 11, 14 and an oxygen. Do you see this? Easy peasy, huh? All right. Now, let's then try. Ooh, I think I should also mention this one here. I don't have to say it's primary alcohol. This one here, what is it? Is it primary or secondary alcohol? The carbon is bonded to only to two other carbons. So this is a secondary alcohol. Okay, it's a secondary alcohol. Okay, it's a secondary alcohol. Okay, that here the carbon is bonded to two other carbons, so it's secondary alcohol. This one here, the OH is bonded to a carbon that is bonded to only one carbon, so it's a primary alcohol. I know the color here is not nice, so it is a primary alcohol. Okay, 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 now proceeding, we are then going to, let me draw this one here. I'm going to say it's CH3, COH, CH3, and then CH3. Ooh, interesting. Let's look at it. How many carbons? 1, 2, 3, 4, 1, 2, 3. I see this one here. There's a substituent. So 1, 2, 3. So it's going to be 3, which will be prop. Right? I see an OH. Therefore, it means the suffix is OL. Isn't it? And then substituent. I see a substituent CH3, which we call methyl. Right? So where's the substituent? Is on carbon number 2. And I can say to you proudly, this will be 2-methyl. The longest chain is 3 carbons. So propan, right? Propan 2-ol, or if you like, you can say it's 2-methyl 2-propanol, whichever you like. Okay. Now let's draw the structural formula of this molecule. It'll be the first one has three hydrogens. The second one has a methyl and an OH. The third one has 3 hydrogens. Right? Do you see this? The third one has 3 hydrogens. Indeed, when we number it, it'll be moja mbili tatu. Right? It'll be moja mbili tatu. Isn't it? Yeah. And this is it, guys. This is how we draw this. Okay. Perfect. Now let's then head to another one. By the way, what kind of an alcohol is this? This alcohol is tertiary, right? It's a tertiary alcohol. Why is it a tertiary alcohol? The OH is bonded to a carbon that's bonded to 3 other carbons. So this is a tertiary alcohol. Happy? Great stuff. Now, let's then head to, I want to try another one. Let me see. Okay, let me see this one here. Let me change the color. Okay, so we're going to try CH2OH in brackets, close, CH open bracket, OH in brackets, CH2CH3. Oh, how we name this one with what I'm seeing? Let me see. One, I see it's not CH3, it's CH, so we gotta start naming from here. 1, 2, 3, 4. So the longest chain is 4 carbons, which we call bute. And then there is an OH, therefore it means the name will end with an ol. And there are two OHs. So this will be 1,2 dibutanol. Otherwise, we prefer butan 1,3 diol. Right? Diol. Now let me show you the structure of this. Let me do this. And then the second one has, and then OH. The third has, was it 3 or 2? Oh, it was 2, guys. It was 2. Okay, my mistake on that, on this one. I will fix it. And then it has 2. Okay, let's fix this one here. It was in blue. So it is 1,2, not 1,3, but 1,2. You guys see it? So here is the structure. Remember, you start numbering at the end nearest the hydroxyl. You cannot 1, 2, 3, 4. You cannot start here. You can only start here, because when you start here, the first hydroxyl is at carbon 3. So we want it to be the lowest number. But when you start here, it is at 1 and 2. So this is the correct, right? Happy? Great. So even here, the molecular formula will be C4H10O, isn't it? C4H10O, something like that. Okay. Right. Ooh, let's see now. Now we're gonna try 4-ethyl octane 2,5 diol. Okay. So oct means 8. Oh, all implies you have an OH. And there are 2 of them. So let's draw 1, 2, 3, 4, 5, 6, 7, 8. The first OH is at carbon number 2. Okay, so because this is more like an alkane, let me do this. So the first one is at carbon number 2, and the other one is at carbon number 5. The other one is at carbon number 5. And then the alkyl is at carbon number 3, so it's fine. Let's place the H's. It's at carbon number 4, so I'm gonna say this is right, H's, 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 H, 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 isn't it? Yeah. Now this is 4-ethyl octane 2.5. Remember, when you number this 1, 2, 3, 4, 5, 6, 7, 8. You can't start 1, 2, 3, 4 because the first one is at 4. We like it to have the lowest number possible. All right. And as you can see, this is your ethyl. It's at carbon number 4. Happy? Now, let's get the condensed structural formula. The condensed structural formula of this guy is CH3, CH open bracket, OH, CH2, CH open bracket, CH2, CH3, done, CH open bracket, OH, yes, followed by CH2, another CH2, and then a CH3. So what kind of an alcohol is this? Yeah, you have to be careful, but yeah, overall I think overall it's a secondary, but the first one is secondary, even this one is secondary. All right, we good? Yeah. So this is it. This is how you draw the structure. Okay, remember it's OH, not HO. It's OH. Okay, great. Now let's draw this one here. Let's draw this one here. Let's see. 1, 2, 3, 4. Let's say, okay, 4 can do it. No, I shouldn't give myself so much work. So let's say H here, H. Let's say another H here, another H here. Let's say you are OH, you are also OH, another H. So how many carbons do we have at most? 1, 2, 3, 4. So this is 4, implying we use but. We see OH, therefore the name will end with OM. So this will be butane. Let's call it butane. Where are the hydroxyl at carbon 2? So it'll be 2,2 diol. Okay, because our numbering starts from here. 1, 2, 3, 4. Remember, it should take the lowest number possible. It should start at the end nearest the hydroxyl. Okay. All right. Otherwise, if you like, you can say this is 2,2 dibutanol. All right, 2.2 dibutanol. Okay. But I prefer this one, honestly. It's nice. It makes you look like you know what you're doing. Okay, so this is it. Butan 2.2 diol, isn't it? Oh yeah. Now let's try last one. The last one will be 2-methyl butan, 2-methyl butan 2,3 diol. Obviously, longest chain is but. So but would mean 4 carbons, isn't it? So but means 4 carbons, and then all imply you will have OH, isn't it? Good. Now let's draw. 1, 2, 3, 4. Where is the OH in carbon 2? There was it in carbon 2 and in carbon 3. Where is the alkyl, the methyl? It's in carbon 2. So here is it. Okay, the H's. All right, here is it. Happy? Good. What is the condensed structural formula of this guy? It is CH3, COH, and then CH3, right? And then CH, open bracket, OH, and then CH3. Happy? So this is 2-methyl butan 2,3 diol, isn't it? So we have come to the end of our video. And remember, guys, if you would like to get in touch with us, Visit our website www.ramtasolutions.co.za. Remember, again, if you want to keep in touch with us on your favorite social media platform, and simply because you're watching on YouTube, the description to our different social media platforms will be given, or rather, the links to your social media platforms will be given in the description of this video. So with that being said, I was Antie and see you next time. Ka jalo re batla gore ra leboga. Thank you. Asante. Rolibua. Enkosi. The next video is aldehydes and ketones. Bye bye.